This is June 21, paper 1, 2, question number 6. It's about the speed of a projectile, and they're asking about how it will vary with time. One thing should be clear. This is not about horizontal speed. This is not about horizontal velocity or vertical velocity. This is about the speed, in fact. The speed could be the magnitude of instantaneous velocity. Now, first of all, I will ask you to understand one concept, that is, sometimes the velocity and the acceleration could be in some different directions. Now, how will this acceleration impact the velocity? You need to resolve the acceleration along and perpendicular to the velocity to see the effect. Basically, first you should focus on the angle. Look, this is the angle theta between the velocity and the acceleration. Now, if you resolve the acceleration, the two components will become, this component will be a cos theta, and the perpendicular component of the acceleration to the velocity, this component will be a sine of theta. Now, if we apply this same concept to the projectile, first of all, you need to understand that for change of velocity, we can go with delta V, for example, in 1 second will be equal to V minus a cos of theta into 1 second. So this is the idea here. Now, if we apply this same concept on the projectile, for the projectile motion at different points, the velocity is at some angle. Like if you want to draw velocity, for example, here it is, this velocity is tangent to the motion. And we know that in the upwards motion, the velocity is going to increase. But the question is whether the increase will be uniform or non-uniform. Initially, the velocity will be maximum, then it is going to decrease, obviously. At the highest point, we are getting the minimum velocity or speed. And obviously, the speed is the magnitude of instantaneous velocity. On the downwards path, the velocity is obviously tangent to the path, and its magnitude is going to increase. Now, if we look for the angle between gravity and velocity, then what we can observe is that the acceleration due to gravity is constant, and obviously it is vertically downwards. What about the angle between acceleration due to gravity and the instantaneous velocity? You have to observe that. If you look carefully, in the upwards motion, this angle is going to increase. This is, for example, theta 1, this is theta 2, and this is theta 3, which is exactly 90 degrees. Yet the important concept is that theta 1 is smaller than theta 2, is smaller than theta 3. So in the upwards motion, the angle between gravitational acceleration and the velocity is increasing. Now, if we resolve the acceleration with the velocity, what we'll get? This component of the acceleration is g cos, say, theta 1. This component that is perpendicular, it will have no impact. It is g sine theta 1. And now if we resolve it here, the angle is bigger. So this is g cos theta 2, and this is g. I'm making a bigger arrow on purpose to make you understand that the sine component is increasing and the cos component is decreasing. Here, g cos of theta 3 is actually g cos of 90, and the deceleration will become instantaneously zero. At this point, for 1 instant, the gravity will have no effect on the velocity, as the velocity is horizontal. Now, the deceleration that we are getting in the upwards motion, it is basically in the upwards motion, deceleration in the upwards motion, we are getting, it is negative g cos of theta, and in the upwards motion, theta is increasing. What is theta? Angle between velocity and acceleration due to gravity. And cos of theta is obviously decreasing. So in the upwards motion, we have decreasing deceleration. So in the upwards motion, we have decreasing deceleration. If we want to represent the speed for the upwards motion, it will be, because in the upwards motion we have a decreasing deceleration. So the speed in the upwards motion, only for the upwards motion, if we draw a graph of speed versus time, what we'll get. So let's call this, for example, this is point A, and for example, this is point B. From A to B, here I think you're able to see point A and point B. From A to B, the speed has a the speed has a decrease with decreasing deceleration. And in this interval, deceleration at any time is the cos component of g. So it's negative g cos of theta. So we are done with the part from A to B. Now, what about the acceleration part when the projectile moves downwards? When the projectile moves downwards, if you look carefully, the gravity remains same. However, the angle of gravity with the velocity is going to decrease. Look, this is a bigger angle, this is a smaller angle, and so on. So this velocity here is, for example, v3. This velocity here is, for example, v4. Now, if we resolve g with this velocity, this component that we are getting, say this is angle theta 4, say this is angle theta 5. Now, in the downwards motion, the angle between velocity and g is decreasing. So the cos component will go on to increase. This is g cos, say, theta 4, and this will be obviously g sine theta 4. Here it will be g cos theta 5, and this will be g sine theta 5. With the decrease of angle, cos will increase and sine will decrease. If you look carefully, in the downwards motion, the component of g that is along the velocity is going to increase. So the remaining part of the graph will be in the upwards motion. Say this is from B to C. This part is C, for example. From B to C, it will be, the speed is increasing, but with increasing acceleration, as the cos component of gravity will go on to increase. So the basic idea here is, if we want to relate this graph with the path, then the basic idea is, if this is the projectile motion, then one thing is, in the upwards motion, the speed is going to decrease. We have a deceleration this big, then the speed is going to decrease, only horizontal component. And then obviously in the downwards motion, the speed is going to increase. Here it will be even bigger, and here it will be, the initial value will be recovered. And if we look for the deceleration and acceleration, then in the upwards motion, we have deceleration that is highest when the angle is smallest. As we go up, this is g cos theta, this will decrease, this is g cos theta. At the highest point, angle will become 90. So g cos 90 will be 0, as gravity is perpendicular to the velocity. So the component of gravity along the velocity will become 0. Now in the downwards motion, this g cos theta will become acceleration, because now it is in the direction of velocity, and it will be increasing now, because the angle is going to decrease. So the projectile has, in the upward motion, it has a deceleration that is decreasing. In the downwards motion, it has acceleration that is increasing. So this is the explanation of this question. And the graph that we are going to select, it is for the speed. And obviously we are going to select speed time graph that represents, in the upwards motion, speed will decrease with a decreasing rate or decreasing deceleration. Reason, angle between gravity and velocity in the upwards motion is going to increase. In the downwards motion, the angle is decreasing, So we have increasing acceleration because the gravity is in the direction of motion. So according to this concept, the option that we are going to select, it is this option, option C. Now, you may think that I could have given you some easier method, but the problem is that if you're not understanding this concept, then the examiner may change the question and then you will feel the trouble. So this was the question, C is the answer, and this is the explanation if you want to take a screenshot. Okay, students, take care.